Hello everyone, so we are from Group A. We'll be presenting our calculus solution regarding Fourier series. So our group consists of me, myself, Abdul Helmi, Fatin Nabila and Rashid Daniel. So this is the question that we were assigned to solve. We were given two types of function, which is pi with the limit of -1 to 1, and the other function is pi x times x minus 3 square over 4 with the limit of 1 to 3. So let's jump into the solution. For question A, we were asked to plot a graph with the interval of -5, 3. So the first step is we have to tabulate all the data for fx value for the both function. But for the first function, it is not necessarily to tabulate data due to the single variable only, and it will be forming a single line only. For the second function, we will be tabulating the data, and this will be the value of x and fx. So this is a graph that has been plotted from the data tabulated that has just been shown just now. So the straight line represents the first function, which is pi from -1 to 1, and the inclined line represents the second function, which is pi x times x minus 3 square over 4 that has a limit from 1 to 3. So from the graph plotted, we can see that the whole period, or p, is equal to 4 due to the range is -1 to 3. So since p is equal to 2l, we will be obtaining the value of L is equal to 2. Since the interval in the question as was -5, 3, therefore we have to plot another cycle with a period of 4. The graph will start at -5 to 3 as a straight line, and -3 to -1 as an inclined line. The distance between each point must be 4, as the cycle period is 4. As we can see from the graph, the second cycle is not reflected at the y-axis, which is the property of even function, and also not being rotated at the origin point, which is the property of odd function. Therefore, we can conclude that this graph is a needed function type due to the inavailability of fitting either even or odd function.
Hi, my name is Fatin Nabila, and I will explain about how we will get A0 and AN. So let's begin. To find A0, we will use the formula 1 over L with the limit -L, we integrate fx dx. So in our question, our fx is pi, and pi x bracket x minus 3 square over 4. So we will plus these two functions fx with their limit, which is -1 to 1, and another function is 1 to 3. So next, it will become, to integrate pi dx, it will be pi x with limit -1 and 1, plus with another term, which is another fx that we already expand the equation with the limit 3 and 1. After that, we will minus the upper limit with the lower limit for the both terms, and then we will get 2 pi plus pi, and then we need to multiply by 1 over 2, and we will get the final answer for A0, which is 3 pi over 2. Next, we will find AN using 1 over L integrate by -LL fx cos n pi x over L dx. So first, we will substitute the value of L, which is 2, into the formula, and then we will use two functions, same as how we get A0, which is we will use two functions, 2fx, which is pi, and pi x bracket x minus 3 square over 4, and we will multiply these two terms with cos n by x over L dx. So as you can see, there's no problem for the first term, but at the second term, I take out pi over 4 as a constant and expand x minus 3 square. So for the second step is, if we integrate pi cos n by x L dx, we will get 2 pi over n pi sine and pi x over 2. And for the second term, we need to use the technique integration by parts to solve these problems. So let me explain about the integration by parts here. So in the integration by parts, we will take the linear equation, which is x cubed minus 6x squared plus 9x as u, and the cosine n pi x over 2 as dv. And then we will differentiate and do the derivative until the u becomes 0. After that, we will arrange them as I put the arrow there for u and dv, for the first term of u using the second term of dv, and continuously until the last dv at 0u. After the integration by part, we will take out and arrange the equation accordingly with their sign, and we will get this fourth term, And after that, we substitute the value of upper and lower limit for the both term. After that, we will continue with the sum expansion here, and we will cancel out to simplify the value and equation. And lastly, we will factorize with the same constant to minimize the terms. So as we can see, this is the final answer for our an, which is 1 over n sine n pi over 2 minus 6 over n cube pi square bracket with sine 3n pi over 2 plus sine n pi over 2 minus 12 over n power of 4 pi cube bracket with cos 3n pi over 2 minus cos n pi over 2.
Thank you, Fatin Nabila. So to continue, I will present the Bn. So Bn, we will use the formula 1 over L integration from 0 to L, or it's L to L fx sin cos n pi x over L dx. So since our L is 2, so the equation is 1 over 2 integration from negative 1 to 3 fx sin n pi x over 2 dx. So we substitute the function into this formula, which 1 over 2 is 1 to 1 pi sin cos n pi x over 2 dx plus 1 to 3 pi and x negative 3 power of 2 over 4 sin cos n pi x over 2 dx. So we bring constant offset from the integration, so pi and pi over 4. So for this one, for this integration, we will use a bipart. So we use a bipart, we use bipart table. So sign positive, negative, positive, negative, positive. So this bipart got 4. 1, 2, 3, 4. 4 steps. 1, 2, 3, 4. So this one is for division and this one is for integration. So we differentiate from x of 3 and x of 2 plus 9x until 0, and for integration until same row as the differentiation. So next, after that, we integrate the equation that we have. So we get this equation after integration. So this one we can integrate normally, and this one we use bipart as previous. We get this equation. So next, we will substitute the value of x into the equation. So one is for the first equation, and one is for the second equation. So one is x is negative 1 and 1, and next is 1 and 3, 3 and 1, 3 and 1. So that we calculate all the equation, and basically we get the answer for the equation.
So for the last part, we just have to combine everything that we have calculated into the formula of fx, which is 1 over 2 a naught plus the summation of an times with cos n pi x over 2 plus bn sine pi n pi x over 2. So this will be substituted by the calculation we did earlier, and we'll get the fx, which is the final Fourier series. Thank you.